Hello viewers, welcome back to another section of my YouTube tutorial videos. In this video, I'm going to take you through the basic concepts of mechanics. So some basic concepts and definitions. So some basic concepts and definitions in mechanics. So stay tuned, watch this video to the end so you understand every part of the video. Kindly subscribe if this is the first time you are visiting this channel. So the first concept that we are going to talk about is what we call a particle. A particle. So now when we say a particle, what is a particle? When we say a particle, what is a particle? So a body assumed to be so small so that it may be regarded as a geometric point. So let's see, when you say a particle, it is a body that is so small so that it is negligible. You get it? So a body assumed to be so small so that it may be regarded as a geometric point. So small to be regarded as a geometric point. So now, when you talk about a particle, it can also be said in the way that it has all its parameters negligible with the exception of what its mass. So when you say a particle, it's so tiny, and normally when you are doing basic mechanics, we represent a particle with just a geometric point, and applications of forces can be represented with arrows against these particles. So take note of particles as you'll be meeting it in your basic mechanics course. You'll be seeing it in mechanics, what a particle is. So when a body is idealized as a particle, the principles of mechanics reduce to a simplified form, since the geometry of the body will not be considered because the body is so small. Hence, mechanics has to reduce to a simplified form to make things easier. Assuming you are dealing with a body like this, you can see that this body here, if you are applying mechanics, the geometry of this body will also have an effect on whatever you do. But in a particle, it's so tiny so that there is no parameters and the geometry is insignificant. For that reason, mechanics of particles is very simplified and direct. Then all forces acting on a particle is assumed to be applied at the same point. So let's see. Assuming you have several forces acting on a particle, these forces are assumed to act at the same point. But on a bigger body like this, you can see that if a force is acting here, the effect is going to be different from a force acting from this side. Likewise, a force acting from this side, right? Yes. Now let's go to the second definition. So we are going to talk about rigid bodies. So when we say rigid bodies, what are rigid bodies? So a rigid body consists of a large number of particles occupying fixed position with respect to another. We've already we've already talked about we've already talked about particle as being an insignificant body whose dimensions are negligible except its mass. So when you have several particles occupying fixed positions, you can see it creates a pattern, and that pattern can be used to draw a solid body. So a rigid body has several particles acting together and they are occupying fixed position to create a uniform body. So now the distance between each pair of particles remains constant. So under all circumstances, if you have a box, the shape of the box is maintained because each particle of the box maintains its position at all circumstances. The size and the shape of rigid bodies are also assumed to remain constant at all times. and that is an assumption used in mechanics. So let's see some point to note. Actual bodies, structures, and machines are never absolutely rigid. So you can't have an absolutely rigid body. It's just an assumed body because the deformations are prone to occur to these bodies. So you can't have a body which is rigid so far as it's being acted upon by a force. Because whenever a force acts on a body, there is going to be a slight deformation. But mechanics assume that these deformations are usually small so that they are not recognizable. So the study of mechanics of particles is a clearly prerequisite to the study of that of rigid bodies. So to know rigid bodies, you should first know that of particles before. Let's go to our third point, and we have what we call a space. A space. A space is a geometric region in which physical events of interest in mechanics occur. So let me write this: a geometric region in which the physical event of interest in mechanics occur. So a space is given in terms of three coordinates measured from a reference point or origin. So a geometric region of events where physical events of interest in mechanics will occur. So with reference from a specific point, you can have this space, which is the XYZ space. So whenever you are doing mechanics and you see the word space, it's just a geometric region, and this region is measured in terms of three coordinates x, y, and z from a reference point O. Now let's go to what we call length. I hope length is a basic quantity we used from the elementary school. A length is used to specify the position of a point in space or the size of a body. So if you have a point in space, as I said, a space is a geometric region. If I have any point here, I can specify the distance of this point from our origin as what we call the length. Length. Length can also be used as the size of a body. Then now let's shortly talk about time. Time is a common quantity used by everyone. So a time is simply the duration or interval between two events. So event A, event B. The interval between these two events is what we call time. Then we have what we call matter. As you know, matter is anything that can occupy space, right? Or that has mass as well as volume. Before you be called a matter, you should possess a mass, then you possess a volume. Then also we have inertia. Inertia. Under mechanics, inertia is of interest. When you talk about inertia, it's a property that causes a body to resist motion. If I have a big stone here and I want to push it, you realize that the stone will not move straight away. Depending on the force, the stone will possess a resistance to the force I'm applying. So inertia is the body's resistance to motion. So if you have a moving car, there is an inertia so that if you apply the brakes, it will be the car will first resist the brakes, and when the brakes are enough or the magnitude of the brake force are enough, it can then stop the car. So inertia is basically the body's internal property to resist motion. Whenever you have anybody resting, maybe a box resting, the box already possesses an inertia so that if you push it with a smaller force, it won't go. Yep. Now, finally, let's talk about the most important of all in mechanics, which is force. Force is the most important quantity in mechanics because for a body to move, change shape, to do any kind of deformation, there should be application of a force. So a force is the action of a body upon another body, as simple like that. So action of a body on another body, that is a force. That is all. What a body will do to another body is what we call a force. So in Newtonian mechanics, Newton, so Newtonian mechanics, we have three absolute concepts, which is what we call the space, time, and mass. These concepts, they are very, very important and they are independent of each other. But force is dependent on space and dependent on time and dependent on mass. So let's see. Let's talk about this concept, which is the scalar quantity. Scalar quantity. So when you say scalar quantity, it's basically a quantity described completely by its magnitude, and direction is not considered. So if I have the length of a box, I only need the magnitude of the length. I don't need the direction of the length. That is a scalar quantity. You have the area of a field. You are only interested in the area of that field, not the direction. But whilst a vector quantity is a quantity which is described by its magnitude as well as the direction. Example is a force. If a force is applied, the magnitude of the force is considered as well as what the direction of that particular force. Okay, so we will end this video here. We end this class here. Thank you for joining me. Please join me in my subsequent classes where we will be solving a lot of mechanics problems. Don't forget to like, subscribe, and share.